And welcome back, everybody. We have Celeste and Marcus with us. Good. And let me go ahead and we're going to cover today the topic of surface areas of a pyramid and of a cone. So with that, Celeste, go ahead and start in reading the first definition.
Altitude of a pyramid or a cone, okay. Right?
Yes.
Sorry. A perpendicular segment that joins the vertex of the pyramid or cone to the center of the base, right?
Yes, exactly. And just to make sure and make it clear for everybody, there's the base, there's my vertex. We have the benefit that that line is what is the known as the altitude of the pyramid. All right, Marcus, go ahead and read the next definition.
Vertex. The blank where the lateral faces meet. The point?
At the point. Yeah, so in this case, we have the benefit it's a point, right? So it's very important for us to be able to determine vertex because it's only one single location that you really find the main vertex of this pyramid. All right, Marcus, go, Celeste, actually, go ahead and read the next one.
Okay. Height. The blank from the vertex to the center of the base.
Okay, so the...
Got it? No.
Yeah, so in this time, it's very important for us to be able to discover height because even though it's used sometimes in the formulas, but it's not a direct thing, it's like a helper. Okay, and we'll discover why as we do more problems. All right, Marcus, go ahead and read the next one.
Slant height. The length of a blank of a lateral face of the pyramid.
Okay, so it's the length of an altitude, yeah. Now, one thing that's very important, and one thing I really want to emphasize that because this term is very new for most of you, is that slab length is actually the length of the side of the face. Okay, now the reason why that's important is because many of your equations are going to use that one. So you would think they're using height, the red one, but in this case, you see the one I'm shaking around, the blue one? It's going to be very important that you're able to discover that slant height so you could use the equations. Now let's go ahead and go to the next one. All right, Celeste, go ahead and read the next definition.
Right cone. A cone whose height is blank to the base.
Okay, so in this case, it's going to be perpendicular. Okay, so it's so as long as you can find a 90-degree here, you're guaranteed, just like a right triangle, you're guaranteed a right cone. All right, Marcus, go ahead and read the next definition.
Regular pyramid. A pyramid whose base is a blank polygon.
Okay, and in this case, it's a regular polygon. Now, the reason why this is important is because irregular polygon does not actually. So let's talk about what a regular polygon is. One thing that I'm able to guarantee you is that with a regular polygon, all the sides are equal and all the angles are equal. All right, now let's have Celeste go ahead and read the definition of a lateral area.
Yes. The lateral area of a regular pyramid is the product of the perimeter P of the base and the slant height L of the pyramid. Yeah,
so one thing that should be not new, you should be familiar with perimeter. The part that is new, the part that I'm gonna have to work with you with in order for you to have the benefit of knowing a little bit better is this part right here. Let me get more color. Oh, it turned black. Hold on a second. Let me erase that. I didn't want to make it black. I wanted to go ahead and show that this is the new part. The thing that is easy for us is that it shows up right here. It's that L that you see on the side. So it's easy to discover. Sometimes it takes a work to get the solution like anything, but it makes sense of where to find it and where to discover it. All right, so Marcus, now what is, that's lateral. The S stands for total. What's the difference between S and L?
Well, the difference is that one has base.
Mm-hmm. Yeah, one has base. So it's important to keep in mind that many applications in our world, you only need to do the sides. Like when you paint a building, you're going to paint the sides of a building. You're not going to paint the base, like the floor, you know? And so, but there's other times where if you're going to ramp a present, you're not going to leave part of it out so people will see it, right? You put wrapping paper all the way around it. So that's a good example, like surface area, where you could wrap it all the way around. So with that, you have to include the lateral plus the base. And so it's very important for you to keep in mind that the B stands for the area of the base. Okay, now let's go ahead and work on some of these examples. So let's go over to, okay, and Marcus. This next couple of questions are going to ask us for lateral area and surface area. Why don't you walk us through, how do you get these solutions? How do you get the solution for the first one?
So we would first have to find the lateral area, then add the base to it to get the surface area.
Okay, good. So how do I find the lateral area?
You just times the perimeter by the slant height, which would be 6 times 4 times 10.
Good, exactly. So it's important to know this perimeter. Now, they went ahead and already discovered the base for us. So that's going to be useful for us. Now, where do we get the lateral area from, Marcus?
You would get the lateral area from the 10.
Yeah, it's pointing to the altitude of the face, okay?
Mm-hmm.
Now, it's important though, because if it was pointing to the height, you couldn't use it. You could not just use that as L. Now, you're gonna discover there's techniques to find what it is, but you could not use it, all right? So let's go ahead and then apply the things you came up with. Their formula, 1/2 perimeter times L, right? So it's gonna be 1/2, 24 times 10, and then we'll get this result, right? Now, what's the only thing I need to do to get total surface area?
You need to add 36, which is the base.
Which is the base. So you see the plus B there? That plus B is gonna have the 36. So as a result, it's easy for us to go ahead and get the solution there. All right, Celeste, why don't you walk us through B? How do we solve for B?
Well, so we first need the perimeter, so we would do 5 times 6.
Yeah, so there's the 30, right?
Mm-hmm.
And then,
so there's 6 sides.
yeah, there it is. Hold on, I'm trying to get that moved out of the way. There you go. Okay, so 6 times 5 is 30, right? Now, what is this? Now, look at the B. You remember how we said B stands for the base of the area? Now, this one had, remember, to find the area of some of these polygons, you have to remember apothem, the idea of apothem. There was a special equation that was in there, and it had the square root of 3 with certain triangles, and that's how they got this area of the base. All right, so now let's go ahead and get, so now what would I do after I discover that, Celeste? If I wanted to find lateral area, what would I do?
Well, for the slant, for the perimeter, it will be 24, and then you would do that.
No, not on this. You're looking at the wrong one. Remember, you did 6 times 5, you have the 30. So that's how you get this 30 that you have here. The 30 here, the 30 here. And then as a result, this arrow's pointing to the slant length, the 6.9.
Mm-hmm.
Okay, so then when we solve all that, we'll get the solution that's really 103.5. Okay, now what would I need to do just to find the total? Yeah, you're gonna add the base.
Add the base.
Yeah, which is that result that were given to us. So we'll have the benefit of knowing that's 168.5. All right, good. Now, Marcus, look at C and tell us what is different about C.
C, it doesn't give you L.
No, what does it give you?
It gives you the height.
Okay, now it's there's actually on there, it's not covered up, but you see the L pointing to the green. What was done in order for them to get that solution, that L that you have there?
The Pythagorean Theorem.
Yeah, and why was that possible?
Because you already had 2 parts. You had the A and B, so they just found out the C.
Yeah.
Which would be slant height.
Yeah. If you could imagine it, there's a cross section. Like if you're able to cross section that little piece there, that cross section will make a right triangle. And with that, you have the benefit of using a squared plus b squared equal to c squared, and then be able to find side length. Okay. So let me move this out of the way. So we have side length, Marcus. So lead us through. How do we solve the rest of this?
Okay, well, you do perimeter times side length, which would be 20 times slant height.
Okay, yeah, so you did 4 times 5 basically, because what you're doing in this case is you're finding the perimeter of the base, okay? And then afterwards, since you already discovered the length, you're saying you're basically find the product of them. So 1/2 20 times that amount. So as a result, we get 103.5. And we'll get this amount, which is, so the only thing, so to find total, we're just gonna add the base, right, Marcus? And so we have that already. So we're just gonna add the b to there. So you discover the 25 added to it, so you get the 128.1. All right, good. Now, Celeste, go ahead and read down the definition above. Read the lateral area.
Okay. The lateral area of a right cone is half the product of the circumference of the base and the slant height of the cone.
All right, good. So read the equation.
L equals pi r L.
All right, excellent. Okay, so one thing that we have to discover is that a cone has a circular type of feature, right? So with it, it makes sense that they're going to start using pi, because we know that's one of the ratios that is a perfect ratio found within circles, okay? So in this case, the only thing that's going to be new in our case is that we're going to now use length, L. Okay. Marcus, what's the only thing that I have to do when I want to find total surface area?
You just have to add the base.
Yeah, and so what equation is that?
That's the equation to find the area of a circle.
Yeah, exactly. So one thing important, lateral is the side, right? Like we said, the sides of the thing. And sometimes you just got to go ahead and find the base, and then you add it all together and you get total surface area. Now let's, Marcus, why don't you lead us through solving the first one? How would you do the first one? And remember, they're asking, remember they're asking for lateral and total. How do you do A?
A, so A wouldn't be that hard. So the radius is 2. So it'd just be 2 times 6, which is 12 pi.
Okay. So basically you got 2 in R, and then L is 6, right? So just like we see there. So that's how you got 12 pi, correct?
And then we do 2 squared, which is 4.
Yeah, so 2 squared.
4 pi.
Yeah, so then if we add all that up, we get 16 pi, which is 150.3, right? All right, Celeste, go ahead and walk us through B. How will we do B on this one?
B, well, so the slant.
What's new about B?
What's new is
Yeah, and you're not the only one, Celeste, but what I want you to notice is that this one, you see everything in green right here? That's Pythagorean Theorem. Okay, and the reason why it was used is because you notice the arrow, we were not given slant length. You see this L right here? Okay, that's going to be important for us to use in the equation. What we were given is the height. And one thing that I'm able to guarantee you is that if you're given the height, you also can go ahead and find out what the, you can use this part right here. This is 6. This is 8. You can go ahead and use Pythagorean Theorem to have the benefit of knowing what L is, which is known as the slant length. So that's the reason why you see all this 6 squared plus 8 squared equal to L squared. Now afterwards, okay, so now you know what L is, Celeste. What would you do next?
what I will do next. So the
Look at the formula. Like Celeste, look at the formula. What needs to go in there?
what needs to go in there is the no. 36, no.
What is R?
R is 6
How do you know?
because it's R equals 6.
Right? Okay, now in this original case, you were not given that. Would you be able to know how to get R? You say you're just given
12 because Well, so since it's at the middle, you do 12, whatever is equal
Yeah,
to.
remember 12 is known as diameter. When you got the entire section across a circle, a radius is half that amount. So that's the reason why R is 6. And then we're given the benefit from Pythagorean Theorem to get the 10. All right. So afterwards, we'll get 60 pi. What's the last thing I need to do if I wanted to find total surface area?
The last thing you need to do is get the base.
All right, good. So can you do that? Yeah, you just have to add the pi r squared, right? So since you still have r is 6, okay, you're going to place it in there, and as a result, you'll get 36 pi added to 60 pi, and you'll get the solution of 86 pi. All right, good. Now let's go ahead and now do this one. All right, Marcus, why don't you go ahead and lead us through example 3? Or read to us.
The surface area of a cone is 16.8 pi inches squared. The radius is 3 inches. What is the slant's height?
All right, good. So what's new about this one?
You're given the surface area, but you're not given the slant height.
Okay, good.
Or
So
even this height at all.
all right, good. So how can I go ahead and solve for example 3?
With algebra, yeah.
Yeah, no, but lead me through the algebra. Well, what I need.
Okay, well, so let's just, get out the equation, and then you would have to plug in your values.
Okay, so what would I plug into this equation?
So you would replace S with 16.8 pi, and both R's with 3.
Okay, good.
Then after you do that, okay, yeah, exactly.
Yes.
So then you would subtract 3 squared pi from 16.8, which would get you 7.8 pi.
Yeah.
And then you'd divide 3 pi from both sides to get L by itself.
Yes.
Which gets you 2.6.
Good. All right, excellent. Okay, good. Hey, listen, we'll go ahead and stop there. Thank you guys for joining us. Okay, so everybody say, go ahead and say bye. And
Bye.
all right, take care, guys.